Here we are in our last example for Module 5.1, the Introduction to Exponential Functions. Kind of putting it all together now in a first application, certainly a first monetary business type application of exponential functions, where we are given some information and asked to work through and find more information based on the given. Let's see how we work through this word problem. As I do with any word problem, the first and foremost, I'm going to just read the problem. Not try to solve the problem yet, just read the problem. A car was valued at $38,000 in the year 2007. By 2013, the value had depreciated to $11,000. If the car's value continues to drop by the same percentage, what will it be worth by 2017? All right, so we're going to translate that and just think about what are they asking us to find? They're asking us to find the car's value, how much it'll be worth in the year 2017. And to do that, we need to figure out, well, how much is it depreciating by each year? How much is it decreasing by every year? And be able to calculate that out to 2017. By far the best and surest way to do that is to, as we saw in examples 9 and 10 in the last video, create a function that represents and models this depreciation, and then use that function. Go one step farther than we did in the last example and actually use that function to calculate a future value, to calculate another value and interpret what we're given, the information that we're given and the information that we calculate there. So let's do that. To do that, like we saw in examples 9 and 10, we need to, if we're going to find a function here, if we're going to formulate an equation of an exponential function here, then we need points. Just like we saw in examples 9 and 10, we need 2 points. And I've got 2 points, I've got 2 pieces of information here. In the year 2007, the car was worth $38,000. That's one pair. That's a time and a value. And I have another pair, a time and a value. By 2013, the value had depreciated to $11,000. Finally, they ask, what will it be worth in 2017? That's a time, and I'm looking for a value. So let's use the time value pairs, the ordered pairs, the points that we know to work out a function here, and then use that function to answer the question that we're asked. Here, I've got the point 0,38, which, as we saw in examples 9 and 10, can then be plugged in to find my a value. Since b to the 0 is 1, a equals 38. So far, so good. Of course, there are some, if not many, of you out there watching this video saying, wait a second, where did the 0,38 come from? I don't see that in the problem here. Let's do some interpreting. Let's go back and say, if the car was first purchased, which it doesn't specifically say it was first purchased, but we can infer from the wording of the problem pretty easily by reading here in the year 2007. That it was purchased in the year 2007, and I'm going to interpret that as my time 0. Time 0 is the year 2007. And then it was valued at $38,000 there. For purposes of calculation, I'm just going to say that the value there is 38. Thinking, in fact, let me write this out specifically, that my time t is in years since 2007. So in 2007, I've gone 0 years since 2007. I'm still at the initial point of purchase. Then my, let's call it V for value, is in thousands of dollars. So thousands of dollars in value. There's nothing magic about me saying that I'm going to use the number 38 and say that that's in thousands, 38 thousands, but it's a lot easier for me to do the math on the number 38 as opposed to the number 38,000. You can use 38,000 and you'll get the same correct answer if you do all the math right in the end. I would rather use the number 38. And remember that we're talking about thousands of dollars. And you'll get some practice on your homework where you're doing that. Like we saw in a previous class notes example, the population of India in billions. It's a lot easier to write the number 1.25, as we did in that example, to write the number 1.25 and say that's in billions of people, as opposed to 1,250,000,000,000. It's easier to write the number 38 in this example and say that's 38. That means 38 thousands of dollars, $38,000. So we'll do that very frequently just to make the math easier to write out. We'll transform the data and say, instead of using 2007 for the year, I'm just going to call that year 0. And instead of using the year 2013, I'm going to call that 6 years after 2007. So that I've got 6 years later a value of $11,000. I just found my A to be 38, B to the 6th power equals 11. And now we'll solve for B, dividing by 38 and then taking the 6th root. We've got B is equal to the 6th root of 11 over 38. And that's not a nice number. That's not a pretty number, but that's okay. That's a number that the calculator understands. And I'm just going to leave it just like that, the 6th root of 11 over 38. So that my function is the value at time t, v of t equals a, which is 38, times b, which is the 6th root of 11 over 38, to the t power. I've got my function now. Yes, it's ugly. Get over it. We've got calculators. We're okay. Here, I've got my function. Now I can actually answer the question, what will the car's worth be in the year 2017? So if t is years since 2007, then 2017 is 10 years since 2007. That means I'm going to plug 10 in for t. And I'm going to find v of 10 to be 38 times the 6th root of 11 over 38 to the 10th power, which is 11 over 38 to the 10 over 6 power, which I can plug into my calculator. And if I do the math correctly in my calculator, I get 4.81355, and I've rounded there. But I took it out that far so that I could then translate that back into a dollar amount. It's not worth $4.81. This, remember, is in thousands of dollars. So I have to move that over and say it's $4,813. In 2017, the car will be worth about $4,813.55.